Okay, so as I've just said, these methods do not work for multi-seasonalities. So something like you have a daily series, or you have an hourly series that has a daily seasonality, weekly, and yearly seasonality. So you could have 3 different seasonalities in one series. So there is where, for example, TBATS would be the traditional method. TBATS stands for trigonometric seasonality, Box-Cox transformation, ARIMA errors, trend, and seasonal components. Okay, by now, hopefully you know what most of these things are. So ARIMA errors, that's just you run an ARIMA on your errors. Trend, seasonal components, you extract components. Box-Cox transformation, we've seen that. And now trigonometric seasonality, that means you use kind of sine and cosine terms to model seasonality. And these are called Fourier terms. Yeah, and so it is basically a combination of Fourier terms with exponential smoothing. It also performs a decomposition of the time series, so that's the same as an ETS. It is again a fully automatic method to forecast series with multiple seasonalities and also with non-integer seasonalities. Right? What is a non-integer seasonality? A yearly seasonality, often people put a yearly seasonality on a daily time series. People would say, it's 365. Yes, but a year is not exactly 365 days long. So we have an additional day every 4 years. So more correct yearly seasonality would be 365.25. And that's now a non-integer seasonality. TBATS is often really slow to fit, especially for long series, and series with multiple seasonalities tend to be long. So I think it's a great comparison method, but yeah, sometimes a bit slow to fit. Yeah, and here I give you an example. So this is some call volume. So basically these are, I don't know, call center time series. Yeah, where you model here the seasonality. And here this is, yeah, exactly. Okay. Another model to mention is Prophet. So Prophet was developed initially by Facebook, which often gives this stamp of quality. You know, it comes from Facebook, it must be good. I would be a bit careful with that. It has a native implementation in Python already many years back. So at a time where there were not many forecasting methods in Python, that's probably why it became so popular, right? So it's kind of the most popular forecasting method. And the question is really why? Because it's not really that special. But yeah, it's because it's in Python and it has a famous name attached to it. To be fair, it's very easy to use and flexible. It is also based on decomposing the time series. The trends can have change points. The very important part about it is that it has no autoregressive components. So it is purely a regression of the series at time t onto components at time t. So there is no t-1 or anything like that. So you just, yeah, so you say, I have these trends and trigonometric seasonalities. So here G is the trend growth term, S the seasonality, and H are some holiday effects. And now you just perform a regression from your data onto this. And because there are no lags, the good thing is you can easily just extrapolate it into the future as long as you want. So it's quite easy to use, and it has some nice properties. But what I think is a very important point is that it is intended for interactive forecasting and flexible model adjusting. So the main idea of Prophet was that, okay, well, I have some business knowledge, like the higher ups have told me this is more or less what we expect, and now we need to incorporate that into our forecast. And now Profit lets you do that. So it's all about interaction with the forecast, flexibly choosing certain trend forms and so on. And what that does is that, yeah, it's not too special in terms of accuracy, especially in the short term, because it doesn't have autoregressive components. And people then start using it fully automatically. People would be like, okay, let's take these 5,000 time series and run Profit on it. And then they are surprised that they don't get good accuracy. Yeah, well, that's not what Profit was meant for in the beginning. On the flip side, I've also seen cases where Profit worked really, really well for whichever reasons. So, yeah, I mean, certainly worth a try. This concludes this part on the traditional forecasting models. It was a quick overview of just some of the most important topics in this section, and stay tuned for the next section, which is going to be a brief history of forecasting competitions.